Hi, I am Apoorv Bapat. I am working in Altair Engineering. So today we are going to discuss about what is FEM, how software interpolates the results, what is degree of freedom. So these are the theory topics which we are going to cover in this webinar session. So let's start the session with what is FEM. We can broadly classify FEM as it is a numerical method. Mathematical representation of actual problem is done in FEM, and FEM is a approximate method. The FEM means finite element method. This term is mainly used in industries, and the term which is similar to this used as finite element analysis, it is mainly used in academics, but there is no as such difference in both FEM and FEA. So the finite element method only makes calculation at limited finite number of points and then interpolate the results for entire domain, surface or volume. As you can see in this example, this circle has infinite degrees of freedom, and the calculations are the number of points are infinite in this for this geometry. If we consider degrees of freedom per point is 6, so the total equations generated will be infinite. But if we find out some of the in between calculation points, or if we create some nodes in between this, so if you can see here we have created some 8 nodes in between this region, and if we find out the interpolation function, now the degrees of freedom per node will be 6, so the total number of equations generated by the software is around 48. So this can be calculated easily by a discretization method. By defining each and every word of a finite element method, we can wholly define what is FEM. So we'll explain one by one what is finite. Any continuous object has infinite degrees of freedom, and it is not possible to solve the problem in this format. The finite element method reduces the degrees of freedom from infinite to finite with the help of discretization or meshing nodes and elements. Now, element, all the calculations are made at a limited number of points known as node. The entity joining nodes and forming a specific shape such as quadrilateral or triangular is known as element. To get the value of variable, say displacement, anywhere in between calculation point and interpolation function as per the shape of element is used. In this way, software calculates the result for the entire domain. If we want to define method, so there are 3 methods to solve any engineering problem. Finite element analysis belongs to numerical method. So we'll go to the next, that how the results are interpolated from a few calculation points. Is it okay that FEA is making all the calculation at a limited number of points, but the question is how to calculate values of unknown somewhere in between the calculation points. This is achieved by interpolation. Consider a 4-noded quadrilateral element as shown in figure below. A quad 4 element uses the following linear interpolation formula: Q is equals to A0 plus A1x plus A2y plus A3xy. FEA or FEM calculates the value at the outer nodes, that is 1, 2, 3 and 4. That is A10, A0, A1, A2 and A3 are known. Then the value of variable in between, anywhere in between could be easily determined by just specifying x and y coordinate in the above equation. For a 8-noded quadrilateral, the following parabolic interpolation function is used: U is equals to A0 plus A1x plus a2y plus a3xy plus a4x square plus a5y square plus a6x square y plus a7xy square. So for 8-noded quadrilateral, the software calculates the value of, say, displacement or stress for these locations, and then the interpolation function, with the help of interpolation function, if we want to find anywhere in between any point, we have to just specify the coordinate of x and y, and just we have to put these values in above equation to find the value of this, say, displacement or stress in between these elements. In the similar manner, the software calculates the value of stress and displacement for the entire domain. Then we will move to the next topic, that what is degrees of freedom and what is DOF. DOF means degrees of freedom. In the example above, an object is fixed at one end and a force is applied at point P. Due to the force, the object deforms and point P gets shifted to new position P dash. That is, if we are applying a force at this point, so due to the application of force, the point P is shifted to a new position P dash. When can we say that we know the solution of above problem? If and only if we are able to define the deformed position of each and every particle completely. So we can say we know the solution of the deformed position, or we can find out what is the deformed position only if we have all the coordinates or all the definitions of this point, that we can define this point completely in space. So the minimum number of parameters, that is motion, coordinates, temperature, etc., required to define the position of any entity completely in space is known as degrees of freedom. Consider the following 2D planar problem. Suppose the origin is at bottom left corner and is known. To define the position of point A completely with respect to origin, we need two parameters, that is x1 and y1. In other words, two degrees of freedom, that is translation along x-axis and translation along y-axis. So in this way we can define a point completely in space. Now consider that the point A is a part of line. Now one angle should also be defined in addition to the two translations, that is 3 degrees of freedom, two translations, that is translation along y and translation along x, and one rotation, that is rotation about any one axis. Suppose the point A and B are shifted out of the plane and the line is rotated arbitrarily with respect to all the three axes. The minimum number of parameters to define the position of point A completely would be 6 degrees of freedoms, that is 6 DOFs, 3 translation, ux, uy, uz. Ux means translation along x-axis, uy means translation along y-axis, uz means translation along z-axis, and 3 rotations, that is theta x, theta y, and theta z, that is rotation about x-axis, theta y is rotation about y-axis, and theta z means rotation about z-axis. DOF is very important concept. In FEA, we use it for individual calculation points. The total degrees of freedom or the total DOFs for a given mesh model is equal to number of nodes multiplied by the number of degrees of freedom per node. So in this way we have ended with the basic theory of FEM. Okay.